then what else we got? Stop this. Okay, now. All right, Isaiah, she back from break? Okay, I see your message. All right, well, if it's okay with you, at least until Danny gets here, I'm going to go through some more of the steps of the problem so you can finish that up. And then we're going to switch back to, I'm going to reteach it, but then I'm going to need you to use that time if you finish it up quick enough to look at your, I think your computer science stuff, because I got to check again. I think you're decent, but I got to see what happened with your storybook. So you can use that time to present it, because that's what the day is all about, just presenting your works. And let's get started. So come back to this. Need to really bring that grade up. Yeah, we can talk about it. I think everybody submitted the extra credit, but they didn't submit the actual storybook. So I don't know what happened there, but we'll talk about it. So let me knock this out for you, because when Danny comes in, I gotta redo it, or I probably might just let her go through the steps. Okay, so let's go through it. You have uh, the algebra part, right? And here's why I said we had to do that. So I'm gonna take this part. I think I'm gonna use a shorthand version of it, and I might even see if I can find the symbol. All right. So now for what is it? Delta. I don't want to put it in like that. So solve for delta Q. All right. Papers all over my desk. Give me a second. I gotta rearrange this stuff. Some room. All right. So now solve for delta Q using algebra. And I forgot to say that this is the definition of electric current up here. How can I expect y'all to be consistent if I'm not? Now, this part, I forgot to put that in there too. Equation of charges of electrons. So now that looks a lot better. We got another quiz. I think it's probably the final quiz. Because if I look at the calendar, this program ends on the 30th. So that'll be your last and final quiz. Can't really do finals and all that because it's a short time period. But this is this. We're coming towards the end. And this is this. Okay. So now that we got that, I'm saying in brackets use, so you know where I'm getting this from. We'll just put definition of electric current so it doesn't get confusing. All right. Now it's ready. This looks really small, so I should blow that up. Just change my monitors to see if it was viewable. All right. So we have that. Now we can move on to using it. That's why I want to blow it up. Small stuff like that get under your skin. And if I go too far, um, Make sure. Okay, I did. Okay. So let's go back to it. We're going to use this equation here, which is inside of our definition of electric current. And plug that here. I want to make it line up to the side because we're going to do steps of that. Now, remember, this is just a definition. I'm going to take this again and I'm going to shorthand write it so we can use algebra on it. And like I said, I want to replace these with some familiar mathematical symbols. So I'm going to go to Insert, Special Characters, and I talked about delta before. So I don't want arrows, I want math. And inside of, it won't move. Oh, there it goes. So yeah, it has it, delta. And I don't want delta to go there. I want it to go here. That's what it means. I also want it to go here. So this is what I try to get you guys to use in school, but you know, ooh, something went wrong right there. There we go. And also this one. Okay. So that makes sense now. I should have left that as is, but this is the part I'm gonna do some algebra on. That's why I did that. So you just follow what I'm thinking about. Um, it is known as amps already. That's what it's measured in. But these are actually called delta T and delta Q. So we're gonna leave those as is. Now, I want to rewrite this because I want to set it up in fractional form so you can see everything cancel out. We have I is equal to, we're going to put delta Q there, copy, all right, and then we're going to make a fraction bar underneath because we're setting it up to do some algebra on it to get delta Q by itself. Real easy algebra step if you know what you're doing. So put this down there. And that's for our delta T. So delta T is in seconds, delta Q is in coulombs. Let's move you over a little bit. So now we can do, like I said, some algebra on this. And I'll take this and I'm gonna move that down because we're in the algebra step. And now, like I said, we want to get it by itself. So you see delta T is being divided. The reverse of division, of course, is multiplication. So I'm gonna say, hey, I want to multiply delta T on both sides of the equation. And I gotta move this all over, so can you bear with me because I need space to multiply it on the other side of the equation. All right, so what you do to one side, you gotta do to the other, and maybe it's best if I put it in the middle. I think it'd be best.
Tyler, can you show me how to do the triangles?
Yes. Give me one moment. So let's see if I can fix this up. That looks a little bit better. Now, the deltas you wanted to know about, let me pause here. You go to Insert, and then you come down to your special characters, and you get this menu. So it starts off with arrows, but you can click on it, not symbols, but you click on which type you want and go to math. So it'll start with arrows, you click on math, and you go through and look, there is the delta symbol, or the triangle as you said. You click on that and it'll insert it in there and you can use it over and over if you copy and paste it. Does that help or are you still having trouble?
Yeah, thank you.
Okay. So now I'm gonna, what did I say? I was gonna just multiply this on both sides of the equation. So I'm gonna just take this one more time. I'm gonna put this over here now. And the reason I did that is because I want it very visible. I'm gonna have to clean that up. I knew it was gonna do that. Over. No, 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 no. You tripping now. Come here. There we go. So it must be the end of my bar. So I gotta move it over. All right. So move that over. That over. That's just where it fits at. And I'm gonna multiply it, like I said. So I put that there. So now we have the algebraic setup. And I'm doing it like this so you can see every step. This, algebra is not something you get unless you practice it. And I've seen that this helps students understand the steps. So what crosses out? Well, this is delta t over delta t, right? So we can just say, hey, cross those out. Because time, delta t or delta time divided by delta time is going to be 1. All right. And I'm making red again like I usually do, the changes to the equation above. This is what we started with, and now we're doing the algebra parts. So these are changes.
Wait, how do I copy and paste it? It's not letting me like.
You highlight the symbol itself, right?
Yeah, it's not.
Okay, are you able to right click?
No, I have not really. I have the. I don't have a mouse.
Oh, that's gonna be tough. Okay, so you can use your keyboard. You can hold shift if you go to the beginning of the delta, kind of like this. You click if you get to the beginning of it. If you hold shift and you press the directional key over and then come up to edit, you should be able to copy it.
All right, there you go.
Does that help?
Yeah,
All right. You need to get you a mouse, dude. It's only like $10 at the dollar store or something. All right.
they could hook up to the MacBook.
Do you got a USB on there?
Yeah.
Uh-huh.
But
He said, I bet. Okay. So I'm just making sure this is crossed out. There we go. So what's crossed out is delta t over delta t. Even multiplication sign goes with it because that's a whole mathematical process. And you end up with delta q is going to fall down and it's going to be equal to this. So now we got delta q by itself. Let me turn all this off. So I know it's going to be red and striked out when I get down there. Okay, there we go. And then I'm going to come down. What happened here? See, I knew it was tripping, but I'm not going to mess with it. So we end up with a new equation of delta q. Just taking this because we didn't touch it, putting that there, is equivalent to this jazz right here that we created from doing algebra. And what do we end up with? Well, let's take a look. At this point, we can put in our numbers and get delta q. And then once we get delta q, we can come back, use delta q here with the constant we know as E, right? And find the number of electrons, and the problem's done. So the hardest part is really pretty much done with the algebra. Now we're just substituting things in and pulling the ingredients from the problem that was given. So the first thing we want to plug in is our amperage or current, right? And that's 0.26 amps. So this is the equation. I want to just leave that there because that's a step in the calculation process. I'm going to put it again. And now this time we're going to use the values that we were given in the problem. So that's going to be 0.26 amps. And this is the time frame they wanted. I think that was 8.7. Let me go check. Yeah, 8.7 seconds. That was our delta T. So 8.7 seconds. Parentheses around that, so you know that's all one unit. It's the difference between a scalar and a vector. Scalar are just values or magnitudes. Vectors have directions. So what was I doing to this? And do this. Make that all red. And now I'm gonna take this again And then when you put them together, both of these units. Oh, undo. 1 second. I am still teaching, young lady. All right. So, what was I saying? You got this part right here. We're going to copy it. So now we got seconds and coulombs. Like I told you before, um, I'm so yeah, seconds and amps they become coulombs, and that's based upon above. So here we go. We got was it 0.26, and now what we want to do is we want to combine it. We'll take this 8.7 and add 0.26, and then it's not amps anymore. This is going to be coulombs, right? So now we got that. We can take our trusty symbol lab and start that up real quick. Hold on, I gotta pause. All right, sorry about that. So let me continue. You got 8.7 and 0.26, and I'm gonna take that and I'm gonna use where is it at symbol lab. I'm gonna take this whole portion and I'm gonna delete it out. And now we have what? We have 8.7 multiplied by 2.6. That becomes 2.26. So let me do this. Come down one. I want to take this part and that equal sign to, and there we go. And we said that's 2.26, and that's going to be uh, this word here, coulombs. So we're good there. Bold that because we're going to need it in a moment. We got to set up our next part, which is the number of electrons. So let me blow that back up and bold that and make that all the same color. No, that was wrong. It's this one. Okay, wait. You still tripping? No, there we go. There we go. All right. So that's one of our part of our solution, partial solution. Now we got to go back and we got to see what happens when we use n for our equation in a number of electrons that pass through the circuit or the CD player. So I'm gonna say now you. Maybe I could use that statement before. Now use. I just gotta change this up a little bit. So let's do this. Now use. That's too much. And not the definition of electric current, but this here, the equation for the number of electrons. So come here and boom. And this is pretty much not in service here. Why is this here? That doesn't need to be there. We're using this equation up here. And it's really quick to do this because we're just going to plug in what we already have. We have that constant for E. Now we have what we're looking for, which is the delta Q. So let's delve into it. That's going to be the delta Q that we said. We have it above. I should have copied that first. Okay, and so that's that value. Parentheses around so you know it's 1 unit. And it's going to be divided by the value of E, right? But what I should have did is I'll put it back though. I should have left that as a second and then next step, but I can put it back. So E is this right here in coulombs. right? You know why that's there, right? So, oh, because that was a part of the earlier problem. It was inside of the remember part. So, come down here. This is E. Now, you notice this is important because coulombs will cancel out. And this E is actually measured in I want to say coulombs per electrons. Electrons will come upstairs and they'll cancel. But yeah, because it's supposed to be coulomb per electron. So let me make sure that's clear here too. So coulombs per electron, because we got to cancel some stuff out to get electrons. Come back. Okay. And come down. And now we're going to say what? We're going to say that it is actually, what did I say it was? This value here. That 1.6 times 10 to the negative 6 coulombs per electrons. Copy that. And we're going to put that here. Close that in parentheses because that's all one unit, right? Now, what does that become? Well, let me put some things back so we can see our progression. We got to cancel out some dimensions to finish this off. So we used earlier definition of electric current, but now we went into the equation for the number of electrons that were in the system. So I'm going to copy this, put that back so it's a reference point because that was supposed to go here, and I just jumped into the problem. Here we go. So now all I have to do really is I was going to tell you to cancel out your dimensions. So coulombs are already in the bottom because it's being divided. What's going to happen is electrons are going to come into the numerator. So that's what happens when you have a fraction divided by a fraction. The denominator fraction will do a reverse or inversion. So as I stated earlier, I'm going to write this again because there's iterations to this. In engineering, you have what's called iterative thinking. So you go through each iteration trying to find the solution. So here it is. I'm going to put that back. And I'm going to show you what strikes out. So electrons, remember, will come to the numerator of this double fraction. And coulombs will cancel. So let's strike that out. And the coulombs in the bottom will cancel. Because it's like saying Isaiah divided by Isaiah is equal to 1. I know most students will say Isaiah. No, it's not. It's actually 1. Anything divided by itself becomes 1. So you're going to strike out the coulombs. And what's going to happen is we have this totally new equation now. So I'm going to take this and we're going to rewrite it. And I'm going to give us a 10-minute break because I'm not sure if Danny's coming or not. I want to give you time to get all this done so we can just focus on computer science. So again, the coulombs are gone. I can remove this. And then that coulomb is gone. But the electron, because it was in the bottom or the denominator of the fraction, and it was a fraction dimensionally, it comes to the numerator. And that's just all of mathematics. It's an important note. So we'll put that here and remove it from here. But it comes to the numerator. So now it looks exactly the way I was trying to, illustrate it to you. I mean, instead of putting electrons there, well, let's leave it there because the new calculation will simply be, because this is in the numerator, let's just put it in the system so we can finish the problem off. So that's going to be the value of 2.26 was in the numerator divided by what did we say was our, and the actual value of an electron is 10 to the negative 19. I use negative 6 because this is a sample problem before we do the actual quiz next week, Thursday. Not this Thursday, but the Thursday after next. That'll be our final quiz. So, because that's the 30th thing. Yeah. So now this is 1.6. We're at the finish line basically because we just got to calculate this and then plug it in. 1.6 0, multiply it by 10. We're going to raise that to some power, and that's negative 6. So negative 6. Hit enter. What does it give us? It gives us a big number. So you see how many electrons, like we did in that circuit, are flying through that? And this is just the mathematical way to represent what we seen earlier. Now, this will change based upon how many resistors you have in the circuit and how many devices are actually being powered by the circuit. But this gives you a rough mathematical calculation. So let's rewrite it. Let's make a space for it. So number of electrons, right? And copy this and put this down here. We're at the finish line before we go to break. And then we're gonna, probably talk about some computer science and data talking. And then 11:10, you can come into class, give you some time to stretch. You've really been powering it out. So it's 1 4. I just want to write it out before I say it correctly because I'm looking at a small screen. It's 1 2. Wow, that's a lot of electrons. 4 99.99. It's just repeating, so I'm gonna say that. And I think I did that right. So if we're going to say that number, how do we do it? We got to put some commas in there. So the first three is what you do. So that's the first three. Next three. These are thousands of billions. So it's 1,412,499.99. And then don't forget, this is measured in electrons. So I'm going to take electrons. And I'm going to plug this in here. And that's pretty much the end of the problem. So what I want you to do is, I'm gonna underline that because that's the end. The other part was just helpful. You need all these steps, right? So I'm gonna like give you a second. What do you need me to scroll back up to? Because you have the floor. Okay, in the class today with you. But what do you have all this, or do you just want to take a break?
Yeah, I got all of it.
You got all of it? Wow, that was quick. All right. Well, take a 10-minute break. Give people time. And even if you hear me talking, I'm gonna set a clock up here that it'll keep me on track in case Danny or somebody comes into class. But you can take a 10-minute break, and when the bell rings, I'll give you a call back, or I'll at least try to see if you're in the room. Okay, so 10 minutes. And if you're done with it, try to format it and get it ready to put into Edsby so we don't have to worry about it. So a couple minutes and knock that out. All right. So let's take a look here. You get 30 seconds. So Isaiah, I think you said you had it all already. Um, so now I think the only thing left is a quick data talk, and that's here. No, no, no. Yeah, I know. Darn it. I didn't turn you off. I was letting you click off. Gotcha. All right. Let's refresh the screen. All right. So you're pretty solid in this class. Again, it's the substitution method that's bothering you. So when you get time, we can go through a problem either tomorrow, because I mean we had a lot of time because we had that demonstration, but tomorrow we're gonna jump into another problem, but it's gonna probably be parallel circuits. So I don't know. So think about if you want to do that or not. But because I want to leave you time to get ready for the next class and set up your scratch projects. Definitely submit this assignment here in period two and here, because you have this class twice, I guess, for credit to get out on time. So these are the same assignments, just posted here in the other class. Other than that, before you go to break, what I want you to focus on in computer science, where is it? Alvarez, okay. Um, for some reason, what's hurting your grade is you gave me this file, Isaiah, and I don't know what that is. That's a flash player. That's not your actual file. So maybe that was an error or something. You probably put the right files in there for. That's when we did Unit 3 with all the PDFs inside. If you don't remember, so let me come back, because it was like nothing but an executable. I'm like, that's not a scratch file. So the files where you had this, I need you to put that in there. I saw it. And if you don't put anything in, the best I can give you is 60%, because I've seen you demonstrate a lot of it. But to get full credit, I need the files. And also here, for what was our quiz last week, the whole storyboard with the different talk blocks, all you gave was extra credit. So that's why you only got 25%, because that was all it was worth. But I need the whole storyboard project inserted in there too. So take a step back and try to find those files, and just come back to class at 11:10. Okay, are you there?